Good afternoon, everyone. Thank you all for being here. Thank you all for the online participants who I assume are all joining this meeting or in the minutes to come. First, I would like to give the word to Tony Granell from CSIC as our co-host here for this meeting today.
Just a few words. Welcome you in the CSIC offices in Brussels, which is strategically located near the headquarters of Europe. And it's always a pleasure to have scientists that come into our place. I think this is a very good opportunity to get scientists and society together. This is a strategic, I guess, meeting. Because we know energy resources are huge, important for your future. So that's feel at home. It's just anything you really need. Yeah, so contact me. I can do whatever it takes to make you happy. I will do it.
Thank you, Tony. And so this is all in function of the Progress project, which is a research infrastructure project funded by the European Union on the matter of plant genetic resources. And Euroseeds is its project partner and is organizing this meeting today together with project partners, Emphasis, the plant phenotyping research infrastructure. Also great thanks to ECPGR for the online support. And so we will have today first policy session, which is contains a lot of different presentations from a lot of different stakeholders. That was our aim, so that we compile a lot of different inputs. And the idea is then that after the coffee break, there will be a more relaxed stakeholder interactive session where we can go more into detail and address the questions that are raised or have been raised during the presentation. And also for online participants, there is a Q&A. And please feel free there to write down your questions. We will follow those and we'll try to address them or today in this meeting or afterwards. May I ask you on the Q&A, if you formulate there a question, please state who you are, from which organization you are, and also to whom that you direct the question. That can be a presenter, that can be an organization or a stakeholder group, but this will help us to address your questions. Furthermore, for the speakers, just to share, it is one presentation that will facilitate the flow from one presentation to another. There is here the pilot to move the slides. And we have a camera that here detects where sound is coming from, and it will automatically then zoom in on your face, so that also the people online see the person behind the presentation. Furthermore, I wonder if there's anything practical that I need to address. Are there any questions in this room? So the bathroom is at the very end of this room. And so let's go for this marathon of presentations. Plant genetic resources is a complex topic. And it's really with great pleasure I reiterate that so many...
Recording in progress.
So that many different stakeholders are present and important speakers here today. So with that and with the timing, as I will be moderator for the session, I will keep tight on timing. I have 10 seconds left to introduce our coordinator of the Progress project, Giovanni Giuliano from July, yes. So please feel free to join here the floor and present your work. Thank you.
Stay there. Yeah. So hello everybody, thank you for being here. I'm Giovanni Giuliano from ENEA, which is an energy agency. Around the world, some energy agencies deal also with plants. So let me start plants are essential for life on Earth. We all know that. There are about 400,000 species of terrestrial plants, and we use an amazing lot of these species for our food, textile industry, about 40,000 species. They fix CO2, we all know that, and they produce all the organic matter which eventually populates this planet, including our food. This is a map of the biodiversity. The red areas are very biodiverse areas. The yellow or white areas, like the Sahara Desert, are very low biodiversity. So let's move to the next slide. And just to remind you that they fix CO2, and about half of the CO2 that's fixed annually is fixed by terrestrial plants. The other half is marine synthesis. And just to give you an idea of the potential of this fixation, you see on the right the movie of vegetation that becomes green during the summer and then fades away. And this greening of the northern hemisphere during the summer is sufficient to temporarily reverse the growth of CO2. So theoretically, if you have the same coverage of plants, of terrestrial plants throughout the year, the CO2 will not go up, it will go down, actually. Because you see it's a zigzag line that eventually goes up with accumulating CO2. So let's move to the next. Plants are incredible chemists. They synthesize an incredible number of different molecules that we use. Think only of cellulose, the most abundant polymer on Earth, but also specialized metabolites that we use for medicine, like morphine, atropine, azadirachtin, which is an insecticide, artemisinin, which is a very successful anti-malaria, etc. All these are synthesized by plants, and about 20 to 30% of our pharmacopoeia is bio-inspired from plants. But plants are, like all organisms, sensitive to global threats, and pandemics are global threats. And an example of such a pandemic was what passed in history as the Irish potato famine in 1845. So the most part of the Irish poor part of the population relied on potatoes for their subsistence. Phytophthora arrived to Ireland around 1845 from Mexico and wiped out essentially all potato harvest. And this caused in 3 years about 1 million deaths and another million of immigrants to America. So this is just to give you the dimension that a pandemic can, of the damage that a pandemic can do. And since then, there are now Phytophthora-resistant potato varieties, but it's in arm's race. New Phytophthora strains arrive, and new resistant strains are bred, etc., etc., etc. Two present-day threats are the very well-known UG99 black stem rust that was first isolated in Uganda and spreading around the world. It didn't reach yet very densely cultivated areas for wheat, but there is the possibility that we do so in the future. And something that's much closer to us, the Xylella fastidiosa olive syndrome, it arose in 2013, and the red areas are the areas that are permissive of this pathogen around the Mediterranean. So I don't know what happened, it's blocked. Oh, here it is. So how can biodiversity help us to overcome this problem? Well, this is the plant breeding paradigm. You need genetic variation to do crosses and to do then the succession selection. And where do you get the genetic variation from? You get it from two different sources. One is wild relatives. This on the top panel, you see the Solanum demissum, which was the origin of the first resistance gene to Phytophthora and potato. And on the bottom panel, you see the sources of resistance to the UG99 rust. There is both a wild species, which is Edgelop sharonensis, and there are several land races that are also carrying resistance. So we need to preserve this variation, this diversity, as an insurance policy, future pandemics. And is this diversity very widespread? And these are two examples. This is from a very recent paper, the top one, very recent paper published in Wheat. On the right in red, you see the modern varieties. On the left, the traditional land races. And if you make the connections in these three, you see that only two of the groups of the traditional land races are represented in modern varieties. There are 5 groups in which the germplasm did not make it into modern varieties. And this is from a tomato paper that we are writing right now. Tomato was domesticated in Peru and Ecuador, and then it underwent several migrations. And on the right, you see the genetic diversity of the original center of diversity. And then you see the genetic diversity of tomato in these other areas. You see it goes dramatically through these transfers via sea and via land. So this biodiversity is also being threatened by anthropogenic processes. So about in the last Kew Gardens report, it was reported that about 40% of plant species, an incredible percentage, are at least extinction globally in the next century. And this figure fluctuates between 10 and 45% for crop wild relatives. So crop wild relatives, which are the source of the variation for reinforcing outcomes, are also at risk. And it reaches 60% for some other groups. So how do you prevent this loss? There are essentially 3 ways. One is on situ on-farm conservation, which is the most difficult one, because it's very difficult to implement in situ. Then there is ex situ conservation, and it's the one that gives the best guarantees and the best documentation to the genetic resources of the world. And then, of course, there are the seed boards that are very good in case of a global crisis, but they don't have a mandate to distribute material. So it's like a vault in which the seeds are buried in case of catastrophe, but they are not distributed. We are not starting from scratch. So there is an European system coordination of plant genetic resources, which is called ECPGR. There is a catalog, which is known as EURISCO. There are over 10 EU-funded projects in the last 2 framework programs that increase our knowledge and created new materials in several important plant groups like solanacea, cereals, legumes, etc., etc. And here comes the proposal. The proposal is there is this ESFRI program that creates new research infrastructures, and a research infrastructure, like every human endeavor, has a start and hopefully sooner or later an end. We are here. We are at the concept development phase. So progress deals with developing the concepts of this future great research infrastructure. You will hear from Sandra later where we are with this elaboration. Europe funds a series of research infrastructures. This is a table from the last roadmap. There are several of them. But none of them is dedicated to the conservation and improvement of the plants that feed humanity. In my view, this is probably one of the most important ones in order of importance for our survival. So the key messages I want to give you are that plants are essential for the survival of humanity and for the maintenance of healthy ecosystems, that we are on the brink of the sixth largest extinction on the planet, and both species, plant species, and their genetic diversity are threatened. Terrestrial plants are particularly at risk, and the upcoming crisis will be global, not local. Climate change, emerging pathogens, water scarcity, and overpopulation will increasingly require the breeding of novel resilient plant food varieties. Therefore, PGR should be considered a heritage for future generations. They need to be effectively conserved and made freely available for use with clear rules on reciprocity. Some countries don't distribute their own genetic resources, and benefit sharing to all actors in the chain. The second series of messages is that no EU research infrastructure presently addresses the study, conservation, and valorization of PGRs, that the GRACE-RI will have a large impact on several important economic sectors like seed production, agriculture, and in general, the plant-derived bioeconomy. The GRACE-RI will contribute directly or indirectly to the following UN Sustainable Development Goals, like zero hunger, good health and well-being, life on land, decent work and economic growth, and partnerships. And finally, that these problems can only be tackled through a Europe-wide and, in perspective, a global infrastructure on research, conservation, and utilization of PGRs. And that's my last slide. So this is the idea. You have to put together different communities, the research community, the PGR conservation community, the plant breeding community, to build this infrastructure. And this will bring impacts in the agricultural sector and on the plant-based bioproducts, and then the UN Sustainable Development Goals. And that's the one on which I want to finish. Ancient Greeks depicted kairos, or kairos if you prefer, which is the right occasion or moment, as a young man with wings, long hair in the front, and shaved on the back. That means that either you catch the right moment while it's coming to you, or when it's passed by, you cannot catch it anymore. So it's too late. And with this, I will thank you for the attention, and I won't be taking questions because it will be a Q&A session at the end of the session.
Thank you very much, Giovanni. And it was a very interesting setting the scene. It's really worrying also to see that we are losing genetic resources, but it's also a hopeful message that we can play a role in that, and that will be Leire Escajedo from University of the Basque Country. Unfortunately, due to health reasons, she couldn't travel here, but she will be giving her presentation online, and I will make her a little bit visible. It's so you can see it's not an AI voice or anything else. Okay, Leire, the floor.
Okay, thank you very much. Can you hear me well?
Yes, we can hear you well.
Okay. So good morning. Yeah, it's a pity that I cannot be with you all today. I hope you're having a great time in Brussels. Yeah, I'm going to present the international regulatory frameworks in plural that impact access, conservation, and use of PGR. Yeah, the expression impacting regulatory frameworks may be striking. Yeah, however, it is the case, as I will explain, and I think that as many of you know, that the way in which these regulatory frameworks affect PGRs since 1992 is very significant. Yeah. So I have divided this presentation into three short sections. Firstly, I will present the key elements of the regulatory frameworks that are affecting PGRs in terms of access, conservation, and use. Secondly, I will compare the core elements of these regulatory frameworks. And finally, I will highlight some of the remaining challenges, also from the point of view, in all the cases, from the point of view of the European PGR community. Yeah. So the international policy frameworks for PGR could be explained using a diagram which divides the timeline in three parts. Yeah. Prior to 1992, there were any regulatory framework, international regulatory framework at least, for the access, conservation and use of PGR. There were some programs, but not compulsory regulations. The turning point was the Earth Summit, the conference that held in Rio de Janeiro in 1992, where some agreements, including the Convention on Biological Diversity, were signed. Yeah, this is a very relevant conference in the history, and as I will say, the purpose of the conference was not only taking into account the PGR. Yeah, many other things, relevant things for the humanity, were agreed in that conference. And this is something relevant to understand some of the problems we have nowadays regarding the PGR. Yeah. As you see, after the approval of the Convention on Biological Diversity, three main groups of legal instruments came regarding the access, conservation, and use of PGR. On the one hand, we have the Nagoya Protocol. I mentioned it in the very first time, at the very first level, because this is a general instrument. That means that is to be applied by default when any other thing has been approved for a country. Yeah. But prior to it, in 2002, the FAO held an important instrument, the International Plant Treaty, the International Treaty on Plant Genetic Resources for Food and Agriculture. Yeah. Nowadays, this instrument is the one that permits the higher exchange of PGR, even if its scope is focused on some PGR and not in all of them. Yeah. And in addition to those instruments, we have a third group, which are the national regulations based on the CDB, but that do not relate to the Nagoya Protocol or the FAO Treaty. Yeah. As you see, the signatories of the previous one, yeah, okay. 196 countries signed the Convention on Biological Diversity. Only 140 countries signed the Nagoya Protocol, and 149 states signed the Treaty of the FAO, plus the United States. United States is not member of the Convention on Biological Diversity. Yeah. We have a next diagram which explains why this regulation is so complicated. Yeah, because, well, the key elements of the paradigm shift are quite clear, challenging but clear, but the practicalities of this implementation are not so clear. Well, on the one hand, we have that access, conservation, and use of PGR is regulated as a part of a global alliance towards sustainable development for all humans, which is the Convention of Biological Diversity. And the three activities are considered strategical. The control and ownership of PGR belong to the sovereign state, but also belongs to them the responsibility of conservation and also the responsibility of facilitating access. Yeah, so there are many points where all the instruments I have mentioned have coincident principles. What's the problem? Yeah, the problem is that signing all the instruments or signing some of them doesn't mean that legally, automatically all the PGRs of a country get the same legal status. So a country can use the three instruments, I mean the Plant Treaty, the Nagoya Protocol, and also national regulation, and it is completely possible to do it voluntarily. Yeah, so the international framework is not clear for one which is looking for PGRs, because we don't know how each of the states nowadays uses. Yeah, so it's very, very complicated. Yeah, so the frameworks encourage but do not oblige. There are some pools where some PGR are shared, but it's not compulsory. So you have to check what are the PGR that are being shared. For example, in the space of the plant treaty. And cataloging and ex situ conservation seem to be quite easy to get in any of the systems. But for example, in situ accessing in situ to any country seems to be almost impossible. Yeah. So we don't have a system that provides legal certainty to the PGR community. Next one, please. Yeah, and if we compare in detail, as we have said, the Plant Treaty, Nagoya Protocol, and even the national regulation have some coinciding points. Yeah, all of them encourage conservation. All of them say they are trying to facilitate access, and all of them say also that it's necessary to agree some terms of use, the PGR. Yeah, so they include some provisions for the material transfer agreements and some provisions as well regarding the ABS. Yeah, I'm going to compare more or less. Next one, this. We need that's it. I'm going to compare the frameworks. Yeah, in some cases we need bilateral agreements, and in bilateral agreements, everything needs to be agreed, the terms of use within the material transfer agreement, but also how the ABS regime is negotiated. Yeah, what is going to be the way to pay, and what's going to be the pay of any of the uses. Yeah, the FAO Plant Treaty has developed something very interesting, which is a standard transfer material agreement that covers all the relevant provisions, and also a multilateral system that makes it possible to access more easily. But as we will see, it's not perfect. From all point of view. And the Nagoya Protocol at this moment is using bilateral agreements. This space hasn't developed yet a multilateral system, but the governing body is in the process of developing a multilateral system. Yeah, if we compare, I have a new comparison in the next slide. If we compare the advantages and disadvantages of multilateral systems, well, there are many potential advantages. The basis for access is wider. Yeah, for example, the Plant Treaty provides a system where you can see what's available, and you also know which the conditions to access are, and so on. So there are many positive advantages as far as accessing is concerned. Yeah, but there are also some disadvantages. Yeah, because the access is dependent on the effort and dependent on the will of the countries. So if countries do not share much PGR, there's nothing to get from the multilateral system. There is also a problem which is related to the burdens. Yeah, because the standard material transfer agreement has incorporated long life burdens to the commercial use of any of the PGR which is shared through the multilateral system. Yeah, in a bilateral negotiation, a party could get more advantage and get burdens that are probably higher, but not long life, which is more certain from a legal point of view. So those standard material transfer agreements have also some inconvenience. Yeah, and please next. Yeah. So I think that there are many remaining challenges. I'm only going to mention some of them. If you see these images, the European PGR community is very diverse. Yeah, we have on the left, many of the activities related to the access, conservation, and use of PGRs, and there are not many. Yeah, this is only one image, and on the right we have also the same activities, but in a way, what make us imagine how diverse the stakeholders are. Yeah. So next one, please. Yeah, the Rio Summit made a clear commitment by all countries to the humanity, and the contribution must come to be made to that goal. Yeah, must continue to be made to that goal. But from the perspective of the PGR community, however, I think that it should be recalled that access, conservation, and use of PGR are not prohibited by the CBD. Yeah, it seems that they have been blocked, but they are not prohibited. On the contrary, they are encouraged as critical. Yeah, but what is happening? Lacks of legal certainty, bureaucratic difficulties, and unnecessary burdens warn the PGR community against the use of post-1992 PGR, or at least against to some of the uses, yeah, especially commercial uses, and this is a big problem. Yeah, next one, please. So we must overcome this 30 years long impasse. Yeah, the PGR community needs a virtual one-stop desk that offers an expert advice, yeah, a simplified way on the availability and selection of PGRs for different purposes. For the moment, we only have this availability and selection system regarding the plant treaty, and this is to end. Yeah, we need more help on that, and also help for the completion of all procedures to access and use PGR. I think that PGR community needs as well to generate, in cooperation with EU authorities, better possibilities for access and better possibilities for in situ conservation. Yeah, nowadays there are too many problems, and we need to think about alternative ways that are possible within the current regulation, but that probably would ask for us getting out of our comfort zone. Yeah, and finally, I think that PGR community. Oh, sorry. I think that the community needs help to overcome the deep divide that separates legally, bureaucratically, or sometimes simply mentally conservation and basic research from breeding activities. Yeah, this is not a legal divide. In some cases, it's bureaucratical or simply mental divide, and is being very negative for the PGR community. So that's all. Thank you very much for your attention.
Very much. Very much appreciated. I'm not a lawyer, but it's clear that it's a very complex matter that actually impacts the access and use of biodiversity, where sometimes it's questioned why we are not making use of more biodiversity, but the presentation illustrated also what you have to take into account if you want to access that. Yes, there's a question online, and we have a bit of time. So Sandra, will you formulate the question?
Thank you. So this question comes from Nigel Maxter from the University of Birmingham. And he's asking Leire, you say that it is difficult to obtain PGR from in situ on-farm conserved diversity. But this is surely not surprising, as we have virtually no active in situ on-farm conservation. Surely we must first implement in situ on-farm conservation. What is your view on that?
Yeah, sure. Yeah, as I said, in my opinion, the stakeholders that are taking part in conservation nowadays, they manage, organize their activities, taking into account which legal problems could be. Yeah, so they avoid things that could be complicated, and it's much easier, to promote activities that are not in situ or on farm. Yeah, so conservation in situ on farm do need I think some administrative or bureaucratical warrants that nowadays do not seem to be so clear. Yeah, even the way in which the European calls for funding, for research funding are created, do not take into account the active in situ on farm conservation in a clear way. Yeah, I think that we do need to rethink on that, And it's not just a question of a couple of ideas. Yeah, the infrastructure that Giovanni has explained could be very relevant to think about those possibilities that nowadays are being overseen or taken aside because we don't see a clear way to act on them.
Very much. Leire, is there any other questions in the audience? No, then I propose to proceed. Thank you very much, Leire, and please stay with us to follow the further session. So we have had now a bit of context. What are the challenges? What is important for the European Union? Which international regulatory frameworks do we need to take into account? Let's move now to some positive stories where we can see examples, initiatives that are dealing with plant genetic resources, which could be then also as an inspiration for what to expect later from a potential great research infrastructure. So we decided to first present some national initiatives, and with that I would like to invite Theo Van Hintum from the Center for Genetic Resources to give a presentation about CGA.
Thank you, Nick. Everybody's so drilled in timekeeping that I think I got a few spare minutes. I'll probably abuse that, but anyway, thank you for the opportunity to present the Center for Genetic Resources in the Netherlands. I'm in charge of the plant activities there, and it's a pleasure to tell you something about it. Positive side, since it's going well. There are organizations that are going well in this field. Only 5 minutes, it might become 6. As an illustration of a well-functioning national centralized plant genetic resources program. I'll walk you through vision, mission, objectives, then look at the way we are organized and the outputs. It's only 5 minutes, so it's too short to become boring, I think. I didn't try to put too many pictures of freezers and stuff in there. It's mainly words. Anyway, the vision. We have to create a world where there's easy access to sufficient plant genetic resources for the current users and for future use. This is not the case, we have to work on that. That's why we're here, that's why we want to establish a research infrastructure, that's why we need to improve. At the moment, stuff is not properly conserved and hardly accessible. It can be improved relatively easily, I think, and the research infrastructure might help us do that. So as CGN, Center for Genetic Resources, we want to contribute to that better conservation and access, quite obvious. And for that, we have the following objectives. We do have our own ex situ collections, ex situ in freezers. There we concentrated on crops that are important to our country, special focus on vegetables. We serve the entire world. And I dare to say that if we're probably the second biggest distributor of vegetable genetic resources in the world, I think. And we have strict quality management. If you conserve genetic resources, you have to be sure you do it well. You can only lose it once, so we have to maintain a high level of quality. That's a basic concept. On the side, because the most money is spent on that ex situ collection aspect. We do support in my country on farm activities, NGOs. We are involved in studying, raising the awareness, creating access to dropout relatives, which are conserved in nature reserves in my country. We are also, as a Center for Genetic Resources, involved in international policy development. So we're a member of the delegations to the COP of the CBD and the governing body of the international treaty and so forth. It's to those people a relief to have somebody in there who knows about the topic and not only lawyers and politicians, although we know our role, right? And finally, we have a dedicated budget to do research to answer the questions that come up in our work. So to allow us to do our work better. I could give many examples having to do with dropout relative. Now genomics is a big thing. But it's always aimed at improving our services, doing the things better that we're supposed to. How are we organized? Well, we operate on the 5-year mandates. As a statutory task. I mean, the government signed all those treaties and agreements. They can't execute them. They hire us to do it, right? But as a result, they demand us to have quality management because the government has to be sure that we do it well. Why doesn't that happen in the rest of Europe, by the way? But anyway, and we have to be independent of the host organization. The director of the institute where I work can't tell me you have to work on this problem or you can't send material to that institute because it's a competitor. We are independent. This works well. This can be organized. If you want to know how, talk to me. We are working in Wageningen University of Research, and that's great. All that knowledge that's there. We participate in projects and in collaborative activities. This is fantastic. It is rather expensive, right? So our rates are high and square meters in the greenhouse is expensive. So we have to deliver that high quality. We have to be efficient. That's that pressure too. It's not only the government. We have a very good collaboration with Dutch and foreign actors. The breeding industry advises and supports us with regeneration, evaluation, and collecting. That's why we know our users. We know why we're doing it. We know what we're supposed to do. We know what service means. We know what they want from us. We talk about it. We have mandatory interviews with users about how to improve our service. We have a mechanism to check all complaints are discussed in the staff. And we look at ways to prevent that from happening again and so forth. This is all doable, it's not rocket science. But we also have good collaboration with the Dutch NGOs and nature conservation organizations for the purposes that I mentioned. And finally, we play an active role on all kinds of international platforms and initiatives. That's why I'm standing here, I guess, but that goes beyond. It's the Scientific Advisory Committee of the Global Information System of the Treaty. It's the Steering Committee of ECPGR. It's all kinds of stuff and European projects that we participate in because we cannot do it alone. We have to do it together. We need you to help us support, to reach our goals, right? And you need us too. So let's collaborate. And we have some platforms. Let's organize that better by creating a research infrastructure, by the way. Outputs. We have a high quality plant genetic resources program. We were the first gene bank that were quality certified, ISO 9001 in 2004, if I'm not mistaken. And that's really, in the beginning, there was some opposition in the organization. Now everybody's really happy. For several reasons I want to expand. Next, we have a well-managed PGR collection. I dare to say that we won't lose material. Everything is duplicated, triplicated, we regenerate, we do a germination test following the protocols. All those protocols, by the way, are available online. We're transparent. You can see how we do things and criticize me, right? And then we will improve. We distribute about, say, 5,000 accessions annually, given that we only have 23 accessions in the collection. That's quite a lot, keeps us busy. We are busy. Well, we contribute to various networks and initiatives, already mentioned that, EU projects, other initiatives, and that's great. That's collaborating, that's creating synergisms, that's in increasing the effectiveness of our program. And that science on the bottom. And to the right, my big pleasure or my biggest pride in my life, I guess, a paper in Nature Genetics about lattice distribution based on 450 sequenced lattice lines. We're involved in science. We want to know more. We want to know more about our collection because it increases the value of our collection, and users will want to use more and give us back more information. We have mechanisms to assure that. I'm nearly there. That's the thank you slide already, but it's important, these faces of those people. I mean, a gene bank is just as strong as the people that work there, and we have a good group, enthusiastic and motivated. Thank you. Yeah. How many minutes?
You did well. So may I ask Tony,
Yes.
then, as an other example, a national initiative, I took the liberty to edit a bit your slides so that it fits within the time frame. So, but I think all the key elements are there. So, Tony from CSIC, please go ahead.
I just learned I had to be the top day last night at midnight, so it's gonna be like, and I think he's a better person qualified than me in that case, Luis Weiss, that is the director for the natural resources in Spain, so. Let's see. So this is the national research facility in Spain that centralizes most of the natural resources we have. Right here, yeah, sorry, I will repeat. This is the National Research Center in Spain. It used to be ENEA, it's belonging to the agriculture institution in Spain. Now it's CSIC, like the same organization here. And it has the mandate to conserve, coordinate activities to facilitate genetic resources, and it's part of the national program. So similar to probably what happened in the Netherlands, more dedicated to resources in Spain. And it has a number of services similar to that providing genetic material according to the regulation Nagoya Protocol, advise international aspects in terms of genetic resources, coordinating activities in the framework of the National Organization for Natural Resources, etc. So all this is very similar to all the gene banks in all over the places. This slide doesn't fit into the national resources, but it's something that I think is good to bring in here. This is in one of the places that Giovanni was showing that is almost no diversity. This is Saudi Arabia, okay? It's a desert. And still they are thinking that there is a lot of genomic information, genetic resources that make possible life in some of these deserts. So maybe we should not only be looking at plants or microorganisms, they are looking at viruses, they're looking at whatever is under the soil of the desert, because they still live there. It's another big project like this deep ocean project, where they want to go into the ocean, because there are things important there. I just was yesterday in a meeting about new Cas. Cas is this part of the genome editing machinery. We are talking here now about genetic diversity. This is a new technology can introduce new diversity. Maybe diversity is not available, and they are looking for the natural diversity in the deep ocean that will help to modify the genomes in the direction that is needed and maybe not available. And trying to look out of the box here. It's not just about natural national resources, seed banks. It's also looking more into general out of the box. Also, the CSIC is also having a platform integrated all the scientists in the different research institutes, because this National Research Center has genetic resources, but also duplicates of this is work in different institutes belonging to the CSIC, where they do the characterization of the genetic resources. One thing is to have a bank of seeds, another thing is to have information about what these genetic resources will make the genetic resources really valuable. Okay. And this is one of the things we do in a project in which some of the panelists here participate, is characterization. In the case of tomato, there are a huge amount of genetic resources. And this is a global thing, because many of the crops we grow in Europe are not originally in Europe. So the genetic resources in Europe are important, but now we have many crops that come from other countries. So, and the original genetic resources come from all these other countries. Then we need to integrate this into the general scheme. And thank you. Back on that.
Yes, thank you. Thank you very much. So it's good to see the national initiative, but you're also looking outside of, let's say, Spain, deep water in the ocean. It was, I think, very interesting. I wasn't aware about this initiative. So we have now these two, let's say, national initiatives. And next, I would like to invite Roberto Papa to the floor. He will make us aware about the Increase project, which I think was recently a winner of one of the 3 citizen science projects.
Yeah, the first one.
Oh, the first one. Congratulations with that. And yeah, we'll be happy to learn more about this concept of decentralized
Conservation.
conservation.
Yeah, thank you. I have to be fast as I. So this is the project that we developed, this increased project, and we propose the development of decentralized conservation to support the utilization and change the pipeline, the innovation pipeline that is associated to genetic resource conservation. Theo was just saying the importance of doing the gene bank conservation, the ex situ conservation. It is very important, but it's also very costly. So we need to develop a pipeline that exploits all this conserved material. So the classic pipeline is basically collection expedition. We collect genetic resources, we put in a gene bank, and we conserve it in gene banks. Then we have expert users access to the gene banks and develop varieties. But the number of expert users are by definition limited. So the number of outcomes is tend to be slow and not to be many as should be in the context of climate change, biodiversity crisis, and all the things that was said before. And also, in most cases, I don't know, maybe in some cases it happens, but the users are hardly able to bring back the information that are coming from their own work. And this is an important point that we try to address in another aspect of this project to facilitate the utilization of this type of information. And then they find that the new variety are released, but after a long time, and somehow not enough diversity bring back to the fields. Moreover, recently, many citizens ask gene banks directly. I mean, this was some discussion we had also with Andreas a few years ago. And this is clearly not something that can be manageable because the cost, as was said, and quality of conservation is needed, is not possible to be applied and to be used for direct utilization by citizens and users. So we propose in this project to develop a new strategy of decentralized conservation that should complement the ex situ conservation of genetic resources to facilitate exactly the utilization, but at the same time raise awareness among the public on genetic resources. And the idea is that the citizen can be part of this game and could be obtaining several benefits from that. This is what we have done. We started using more than 1,000 accession single citizen lines of common being, mostly random races worldwide. And we developed a citizen science experiment, sending to the citizen 5 varieties of 5 pure lines randomly taken from the 1,000 plus 1 control line that was a very early variety. And we asked them using an app to phenotype this material. This we involved more than 20,000 citizens in the year from 2021 till this year. And this is the distribution map of the citizen in Europe in 2024. We're also starting to exchange seeds between citizens. And all this was done based on an app-based solution. The app is not only useful for exchange, and we have implemented the EasyCMPA release in connection with the GLIS. And so when you take the seed, you accept, you have first, as a citizen, accept the EasyCMPA to the app. And then you get this information and all the transfer to the citizen and from the citizen to citizen, because we allow also exchange between citizens, are based on DOI system. So each step of distribution is taken into account. And so basically, we have a full traceability of the system with the possibility of knowing what we conserve and who is conserving what is conserved in the system. And well, this is the system of, let's say, packing, distribution, and we also distribute this stuff here. It's a color checker and size checker in a way that citizens not only transfer the information of the phenotyping, and I will talk about that tomorrow, but they also are able to make features, and we have a color checker and size check in a way that we can use the information from the feature. We are trying to develop an AI system to implement also artificial intelligence for using the information from citizens. I cut the story. I have more other aspects about that, and I will show it today. One idea is what is the quality of this work? Please, the quality is given as for flowering time, irritability about 60%, and in the whole participation of citizens. And we were able to map UTL that are known, such as in well-known UTL in chromosome 1 in a quite high quality way. So this data doesn't give you a lot of new information about flowering time in common being, but tell you that the citizen data can be exploited powerfully for information and genomics. So we think that we can develop a PCR, let's say, it's not a PCR, a plant genetic resources decentralized conservation, that we can have strict traceability and exploiting the new technology from genomics to information technology as much as possible to get all the information coming back from citizens and improve also the awareness of citizens for that. That is very important because we need to involve citizens for facilitating utilization, because clearly if all this material is in the hand of citizen, this will be easier, but also we have to have the citizen knowing that this aspect is important. So this is the price, and then thank you very much.
Thanks for sharing this initiative. That's great to hear. Did you ever actually expect it to become so big? And what would be your recommendation for anyone who wants to do such an endeavor?
In sense of citizen science,
yes.
Yeah, well, the important is to have some good team, I would say, that is important, and very motivated team that work together to get to the objective. I think that we were able to have a very nice group of people working together.
Thank you.